In 1968, NASCAR inspectors handed Smokey Yunick a list of 9 technical infractions and confiscated his fuel tank to prove his car was illegal. Smokey looked at the officials, climbed into the machine, hit the starter, and drove straight back to his garage without a fuel tank installed. This is legacy motoring, and I spend way too much time thinking about mechanical loopholes, automotive outlaws, and motorsport engineering. If you're someone who loves raw horsepower, ingenious rule bending, and the wild stories of how one brilliant mechanic outsmarted entire multi-million-dollar racing organizations, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Here's the thing about auto racing. From the very second the green flag dropped on the first motorized competition back in the late 19th century, mechanics and drivers understood a fundamental truth. Winning does not come from merely operating inside the lines. It comes from finding the exact boundaries where the ink runs dry. Most people look at a racing rulebook and see a rigid set of strict prohibitions. They see walls, guardrails, and hard limitations. But every once in a while, the sport produces an individual who looks at that exact same document and sees a map of uncharted territory. To really understand how this arms race began, we have to travel back to 1923 and look at a kid named Henry Yunick, born in Neshaminy, Pennsylvania. Growing up on a struggling farm during the Great Depression, Henry learned early on that if something broke, nobody was coming to rescue you. You had to fabricate, weld, adapt, and make machines survive through pure willpower. The nickname Smokey came shortly after, either because of his foul-mouthed demeanor, his constant pipe smoking, or the trail of oil smoke that billowed from his heavily modified home-built machinery. Honestly, depending on which old-timer you ask, all 3 explanations are probably true. When World War II broke out, Smokey took those mechanical instincts into the United States Army Air Forces, piloting B-17 Flying Fortress bombers over Europe. He flew 50 combat missions. Think about that for a second. In an era where the life expectancy of a bomber crew was measured in weeks, surviving 50 combat sorties required more than just courage. It demanded an intimate, visceral understanding of aviation mechanics, fluid dynamics, and operational margins. Smokey learned that machines were not magical artifacts carved in stone by factory god. They were mechanical assemblies bound by physics, airflow, and heat dissipation. Factory specifications were not absolute laws. They were merely the baseline compromise of mass production. After the war ended, Smokey settled down in Daytona Beach, Florida, and opened up a garage on North Beach Street. He painted a bold sign across the front that quickly became world famous: "Best damn garage in town." Daytona Beach in the late 1940s and early 1950s was ground zero for the birth of NASCAR. Bill France Sr. was organizing races on the hard-packed sand, stock car culture was exploding, and moonshiners were trading bootlegging runs for Sunday afternoon trophies. Now, NASCAR back then was an entirely different universe compared to the corporate spectacle we see today. The original rulebook was barely a dozen pages stapled together. It was essentially a list of basic safety guidelines and vague mandates telling teams to run strictly stock automobiles. But the word stock has always been open to interpretation. The rules clearly stated what you could not modify, but they were notoriously silent on what you could do in the spaces between the words. Smokey lived in those spaces. His guiding philosophy was remarkably straightforward, and he repeated it until the day he died. If the rulebook does not explicitly forbid something, that means it is completely legal. To Smokey, exploiting an unwritten rule was not cheating, it was pure, unadulterated engineering. Which brings us directly to one of his earliest and most brilliant masterstrokes, the polished exhaust manifold. In the 1950s and 60s, NASCAR engine builders were locked in a desperate search for breathing room. An internal combustion engine is, at its core, nothing more than a giant air pump. The more air and fuel you can cram into the combustion chamber, and the faster you can scavenge the burnt exhaust gases out of the cylinder head, the more horsepower you generate. Competitors routinely tried porting and polishing the cylinder heads, using metal grinding bits to widen the intake and exhaust runners. NASCAR officials quickly realized what teams were doing and slammed the door shut. The rulebook strictly banned porting and polishing of cylinder heads. Inspectors used internal go-no-go gauges and bore calipers to measure port diameters down to thousandths of an inch. If your cylinder head ports showed grinding marks or deviated from stock factory blueprints, you were disqualified on the spot. Look, most mechanics threw up their hands and accepted the limitation. But Smokey read the exact wording of the rule. The rule specifically banned modifying the cylinder head port. It said absolutely nothing about the interior surface of the cast iron exhaust manifold bolted directly to the head. Here's what most people don't realize about factory cast iron from Detroit in the 1960s. The manufacturing process relied on rough sand casting. The inside of a stock exhaust manifold looked like coarse sandpaper. As spent exhaust gases blasted out of the cylinder at supersonic speeds, they collided with microscopic metal peaks and valleys, creating severe boundary layer turbulence. That turbulence choked the exhaust flow, creating parasitic backpressure that forced the piston to waste precious kinetic energy just pushing spent air out of the motor. Smokey took a stock cast iron manifold, mixed an abrasive metal polishing slurry, and ran it continuously through the internal passages using a custom pump setup. Hour after hour, that abrasive fluid wore down every microscopic imperfection until the interior was as smooth as glass. The inspectors found factory dimensions everywhere, completely oblivious to the fact that Smokey had just rewritten engine physics. Think of it like this. If you try rolling a bowling ball down a gravel road, the friction bleeds off its momentum almost instantly. But if you roll that same ball down polished hardwood, it glides effortlessly with zero lost energy. By smoothing that internal cast iron surface, Smokey turned a violent, turbulent air storm into a laminar flow superhighway. That small, invisible modification gave his cars an immediate tactical edge down the backstretch. And because it left zero machining signatures, it drove technical inspectors absolutely insane. They knew the car was faster, they knew Smokey was behind it, but their micrometers showed nothing illegal. This is where it gets really interesting, because the exhaust manifold was just child's play compared to what Smokey did to NASCAR's fuel regulations. By the mid-1960s, NASCAR realized that pit stop strategy was deciding races. To level the playing field and keep speeds in check, the sanctioning body introduced strict rules capping fuel cell capacity. Depending on the track, cars were mandated to carry a maximum fuel tank size, typically around 22 gallons. Officials took this rule dead seriously. During pre-race technical inspections, inspectors would drain a car's fuel system entirely and pump in exactly 22 gallons from a calibrated measuring container. If the tank overflowed before the 22nd gallon went in, or if it accepted even a fraction of a pint more, the car failed inspection. Now, you might be thinking, how on earth do you bypass a physical fluid volume test when inspectors are standing right over your shoulder with a certified measuring beaker? Well, Smokey approached the problem with two distinct layers of genius. The first method was pure psychological sleight of hand. Before pushing his car through the inspection shed, Smokey would insert an inflatable rubber bladder, often a common basketball or weather balloon, inside the fuel tank through the filler neck. He would inflate the bladder with air, taking up roughly 4 to 5 gallons of interior volume. When NASCAR inspectors pumped their 22 gallons into the tank filled up to the brim exactly at the official cutoff mark. The inspectors checked their clipboards, marked the tank as fully compliant, and slapped an official inspection seal over the cap. Once the car was wheeled back to his pit stall, Smokey simply reached into the filler neck with a long wire needle, punctured the bladder, and pulled the deflated scrap of rubber out with a pair of needle-nose pliers. Just like that, the fuel tank regained its full internal volume, ready to swallow 5 extra gallons of high-octane racing gasoline before the race started. But Smokey didn't stop there. He knew inspectors would eventually get wise to the bladder trick, so he designed a secondary system that was so audaciously simple it defied belief. The NASCAR Rulebook contained pages of exacting specifications dictating the maximum internal dimensions of the sheet metal fuel cell. It specified the gauge of steel, the mounting brackets, the safety foam, and the filler neck diameter. But remember Smokey's golden rule: if the rulebook doesn't say you can't, you can. The rulebook strictly regulated the fuel tank, but it had entirely forgotten to define the maximum diameter or length of the fuel line running from the tank at the back of the car to the carburetor sitting on top of the intake manifold. Standard race cars ran a modest 3/8 inch or half-inch hard line along the frame rail. Smokey looked at that chassis and had an epiphany. He fabricated a custom 2-inch diameter steel fuel line, looping it multiple times through the interior frame rails and subframe cavities before finally connecting it to the fuel pump. That single, oversized fuel pipe snaking through the chassis was over 11 feet long. Here's what most people don't realize: an 11-foot pipe with a 2-inch internal diameter holds nearly 5 full gallons of gasoline. When NASCAR drained and measured his fuel tank, the tank itself held exactly the legal limit of 22 gallons. But the fuel line holding another 5 gallons never registered on their basic check. 5 extra gallons in a stock car during the 1960s translated to roughly 10 to 12 extra green flag laps. While his rivals were forced to make 3 or 4 scheduled fuel stops during a 500-mile race, Smokey's driver could stay out on track, running in clean air, building an insurmountable lead, and effectively skipping an entire pit stop cycle. This led to the most legendary confrontation in NASCAR history. During an exhaustive inspection at Daytona, suspicious officials swarmed Smokey's black and gold Chevelle. They spent hours tearing the car apart with measuring tapes, bore scopes, and template. Frustrated that they couldn't find a smoking gun, an official handed Smokey a punch list of 9 separate items they claimed violated the spirit of the rules, demanding he drop the fuel tank right there on the shop floor for a full teardown. Smokey didn't argue. He calmly unbolted the fuel cell, pulled it out of the trunk, and dropped the 22-gallon metal tank directly at the feet of the lead inspector. Then, with dozens of mechanics and NASCAR executives watching in absolute stunned silence, Smokey reached inside the cockpit, flipped the ignition toggle, pressed the starter switch, and roared the engine to life. He dropped the transmission into first gear, stepped on the throttle, and drove the car all the way back to his garage without a fuel tank installed, relying entirely on the 5 gallons of fuel stored inside his massive frame rail fuel lines. As he drove away, he famously leaned out the window and shouted back, "Make it 10 items on that list, boys." Now, you might think NASCAR immediately banned the practice on the spot. They did, of course, but not before Smokey proved that racing authorities were constantly reacting to innovation rather than anticipating it. Every single victory Smokey notched was not merely an athletic triumph. It was a devastating intellectual defeat for the sport's highest governing body and officials. Yet for all his brilliance with exhaust manifolds and fuel lines, Smokey's undisputed masterpiece was a car that would become the stuff of motorsport folklore: the legendary 1966 black and gold No. 13 Chevrolet Chevelle. Look, if you talk to old-school stock car mechanics today, half of them will swear on a stack of shop manuals that Smokey built a completely illegal 7/8 scale replica of a production Chevelle. The legend goes that he took factory General Motors body blueprints, scaled every single dimension down by 12 to 15%, and hand-fabricated an entire miniature Chevelle body from scratch just to slice through the air like a jet fighter. Now, you might be thinking, did Smokey really build a 7/8 scale car from raw sheet metal? Here's what most people don't realize: the car was not actually 7/8 scale in the literal sense. Building a car proportionally scaled down in every axis would have immediately shown up on NASCAR's wheelbase and track width measurement. What Smokey actually did was far more sophisticated, subtle, and scientifically lethal. He took a stock production Chevelle body and systematically re-engineered its aerodynamic footprint without changing the primary exterior silhouette. Back in the mid-60s, Detroit race cars had the aerodynamic profile of a flying brick. They had massive frontal surface areas, protruding chrome bumpers that acted like air scoops, deep recessed windshields, and flat, vertical grills that shoved high-pressure air directly under the chassis, creating terrifying high-speed lift. Smokey understood aerodynamics long before Formula One or NASCAR teams were spending millions in wind tunnels. He smoothed the entire underside of the Chevelle with a flush belly pan, completely eliminating the turbulence created by the exposed transmission, oil pan, and rear axle. He shaved and tucked the front and rear bumpers tight against the sheet metal, turning blunt obstacles into sleek air dams. He chopped and leaned the windshield and rear window back at a shallower angle, flush-mounting the glass so air could glide over the roofline without separating into turbulent vortexes. But his absolute stroke of genius was what he did to the chassis itself. Because NASCAR oval tracks turn exclusively to the left, symmetrical weight distribution is actually your enemy. In a stock factory configuration, the engine, transmission, and driver sit centered in the chassis. Smokey cut and reconstructed the Chevelle's frame rails, shifting the entire massive big block engine, drivetrain, and driver cockpit 3 inches to the left side of the vehicle. By biasing all the static weight to the inside rail, the car naturally carved through high-speed bank turns at Daytona and Talladega with virtually zero chassis roll. While other drivers were fighting severe tire wear and understeer, Smokey's Chevelle gripped the tarmac as if it were glued down by invisible downforce. He also raised the entire floor pan inside the body shell. By bringing the floor up 3 inches, he was able to drop the exterior body over the chassis, lowering the overall roofline and center of gravity without violating NASCAR's minimum ground clearance rules. The result was an aerodynamic predator. In 1967, legendary driver Curtis Turner climbed into Smokey's black and gold Chevelle at Daytona and uncorked a qualifying run of over 180 miles per hour. At a time when the fastest factory-backed Chrysler and Ford teams were struggling to touch 174, a privateer Chevelle had utterly shattered the track record. NASCAR executives panicked. Bill France Sr. and the Technical Inspection Committee knew that if an independent mechanic humiliated the multi-million-dollar factory teams on live national television, the corporate manufacturers might pull their sponsorship money out of the sport entirely. Inspectors descended on Smokey's Chevelle like a forensic crime squad. They measured the roof height, it passed. They checked the wheelbase, it was factory spec. They measured the track width, perfectly legal. They brought in heavy metal body contour templates to check the fenders, hood, and roofline against standard production cars. This is where it gets really interesting. The Chevelle fit the templates so flawlessly that the inspectors were completely baffled. What they didn't realize until years later was that NASCAR's technical department had constructed their official Chevelle templates using a pre-production GM body provided by Smokey himself months earlier. Smokey had subtly massaged the prototype body before NASCAR even made the templates, ensuring that his radical aerodynamic modifications were literally baked into the official rulebook standard. When NASCAR realized they had been completely outmaneuvered, they resorted to subjective disqualification. They issued a retroactive decree stating that Smokey's Chevelle violated the spirit of stock car competition and refused to allow it to start the race unless Smokey reversed every single custom body modification. Smokey was furious. He knew he had beaten them strictly within the boundaries of their own written rules. Instead of bowing to corporate pressure, Smokey loaded the Chevelle onto his open trailer, packed up his tools, and drove away from Daytona in disgust, vowing never to let NASCAR dictate the terms of his mechanical genius. The Chevelle never won the Daytona 500, but it accomplished something far more enduring. It permanently proved that superior understanding of fluid mechanics, aerodynamics, and chassis dynamics could embarrass the combined engineering might of the global automotive establishment. that Chevelle represented a critical turning point in American motorsport history. It forced NASCAR to abandon its loose, subjective inspection protocols and adopt modern laser-aligned templates and rigid dimensional rulebook. But more importantly, it proved that Smokey was not merely a stock car mechanic tweaking carburetors behind closed garage doors. He was an avant-garde aerospace engineer operating in a world of shade tree mechanics. While the rest of the garage area was still thinking in terms of bigger camshafts and heavier valve springs, Smokey was calculating drag coefficients, boundary layer separation, and cornering weight transfer equations in his head. The sport was changing rapidly, and Smokey was dragging it kicking and screaming into the modern technological era, whether the entire racing establishment was genuinely ready for it or not. When you look at Smokey Yunick's broader career, restricting his legacy to NASCAR would be doing him a massive disservice. His restless mechanical mind refused to stay confined to southern stock car ovals. In the 1950s, 60s, and 70s, Smokey took his radical engineering philosophies directly to the biggest, most prestigious open-wheel race in the world, the Indianapolis 500. And just like in stock car racing, Smokey arrived at the brickyard looking at physics from angles nobody else had ever considered. In 1964, Smokey unveiled one of the most eccentric and daring racing machines ever built. The Hurst Floor Shift Special, affectionately known across the racing world as the Capsule car or the sidecar. Look, open-wheel Indy cars of that era were front-engine roadsters or emerging rear-engine chassis where the driver sat directly along the vehicle's centerline. Smokey took one look at the Indianapolis Motor Speedway, a rectangular track with 4 distinct left-hand turns, and realized that conventional symmetrical race car design was fundamentally inefficient. He designed a radical asymmetrical race car where the engine, fuel tank, and drivetrain were housed in the main fuselage on the left side of the vehicle, while the driver sat suspended in a lightweight, aerodynamic pod mounted between the left side wheels, completely isolated from the heat, vibration, and mechanical noise of the power plant. The engineering logic was brilliant. By concentrating 80% of the vehicle's static and dynamic weight on the left side, the car could corner at unprecedented speeds without loading the right side tires to catastrophic failure. USAC officials were so terrified by the car's radical configuration and blistering cornering potential that they banned asymmetrical cockpit pods from ever competing in the race, citing safety concerns. Smokey didn't quit. He was among the earliest pioneers to experiment with aerodynamic wings on open-wheel race cars, years before Formula One teams officially embraced inverted airfoils to generate downforce. He also experimented with turbocharging, building radical twin-turbocharged Offenhauser 4-cylinder racing engines that were capable of producing well over 1,000 horsepower on methanol fuel. This is where it gets really interesting, because while racing brought Smokey fame and notoriety, his greatest technological achievement had nothing to do with turning laps on a racetrack. It was an engine designed to solve the global energy crisis. The patented Smokey Yunick hot vapor engine. During the late 1970s and early 1980s, the global automotive industry was thrown into absolute chaos by the OPEC oil embargoes and strict new federal emissions mandate. Detroit was choking its massive V8 engines with primitive smog pumps, restrictive exhaust headers, and detuned carburetors, resulting in sluggish, unreliable cars that could barely manage 15 miles per gallon. Smokey looked at the entire automotive manufacturing sector and declared that conventional engine design was wasting more than 70% of the energy contained in every gallon of gasoline. Here's what most people don't realize about the physics of internal combustion. In a standard engine, liquid gasoline is sprayed into the intake manifold or cylinder as a mist of tiny liquid droplet. But liquid gasoline does not burn. Only gasoline vapor burns. When the spark plug fires, the flame front has to heat and vaporize those liquid droplets before they can combust. This creates uneven flame propagation, unburnt hydrocarbon emissions, and massive thermodynamic losses. In fact, a typical production car engine in 1980 had a thermal efficiency rating of barely 25%. The remaining 75% of the fuel's energy was lost as wasted heat radiating through the radiator and out the tailpipe. Smokey asked a revolutionary question. Instead of throwing that waste heat away, what if we use the exhaust heat to completely homogenize and vaporize the fuel before it enters the combustion chamber? He took a standard, anemic 2.5-liter Pontiac Iron Duke 4-cylinder engine, an engine that produced a pathetic 84 horsepower from the factory, and completely redesigned its intake and thermodynamic. He routed the incoming air-fuel mixture through a specialized exhaust-heated heat exchanger and an intake homogenizer spinning at high speed. By the time the air-fuel charge entered the combustion chambers, the gasoline had undergone a complete phase change from liquid mist into a superheated, dry, gaseous vapor at over 200 degrees Fahrenheit. Now, conventional automotive wisdom said that introducing superheated air into an engine would cause catastrophic preignition, detonation, and melted pistons. But Smokey precisely tuned the fuel-air ratios, intake swirl, and combustion chamber geometry to eliminate engine knock entirely. The results were so shocking that major automakers and government agencies refused to believe the dyno readouts until they verified them with their own calibrated sensors. Smokey's hot vapor engine produced 250 horsepower and 250 pound-feet of torque out of that tiny 2.5-liter four-cylinder. That was nearly triple the factory power output. But here is the kicker. Installed in a production passenger car, the engine achieved 51 miles per gallon on the highway while meeting federal tailpipe emissions standards without using a catalytic converter. Think about those numbers for a moment. In 1983, an independent mechanic working out of a Daytona Beach garage built an engine with a thermal efficiency approaching 45%, a number that modern hybrid powertrains still struggle to achieve today with billion-dollar electronic controls and direct injection. Engineers from General Motors, Ford, and the Environmental Protection Agency tested the engine extensively. But corporate politics, manufacturing costs, and the rapid emergence of electronic fuel injection meant the hot vapor engine was never put into mass production. Smokey held multiple patents on the design, standing as living proof that true automotive innovation often comes from lone geniuses, not corporate committees. It was this exact refusal to accept traditional limitations that made Smokey both revered and feared throughout the automotive world. Whether he was designing experimental military machinery, redesigning the internal combustion engine, or bending a racing rulebook to the absolute breaking point, Henry Yunick proved that true mechanical genius does not ask for permission. It simply goes out and builds a faster working reality. When you step back and look at the modern landscape of motorsport, you realize that the ghost of Smokey Yunick still haunts every technical inspection shed in the world. Today, the NASCAR Cup Series rulebook is not a dozen stapled pages handed out at a driver's meeting. It is a massive, encrypted digital catalog spanning hundreds of pages of microtolerances, CAD geometry files, laser optical scanning protocols, and spec part mandate. Every single car on the grid is measured down to the thickness of a human hair by multi-axis laser scanning rig. If a body panel deviates by 30,000ths of an inch, the team is slapped with points penalties and crew chief suspensions. Here's what most people don't realize. That gargantuan, suffocating modern rulebook is not a tribute to bureaucratic efficiency. It is a monument to Smokey Yunick. Every single restrictive clause in that book, every rule stating that manifold runners cannot be smoothed, every regulation dictating the precise internal diameter and path of a fuel line, every mandate enforcing factory chassis symmetry, and every template applied across a quarter panel, exists solely because one man in a white cowboy hat with a pipe clenched between his teeth figured out how to beat them without it. NASCAR didn't write those rules to spark creativity. They wrote them to survive Smokey. Look, there is an undeniable sense of nostalgia when you look back at that golden era of American racing. We have traded the era of the rogue mechanical polymath for the era of corporate simulation engineers running aerodynamic algorithms on supercomputers. Back then, an independent mechanic armed with an abrasive slurry, a set of hand tools, an intimate grasp of fluid dynamics, and pure audacity could build a car in a Daytona Beach garage and utterly humiliate General Motors, Ford, and Chrysler on Sunday afternoon. Smokey operated in the moral gray area of competition, but he never apologized for a single millimeter he gained. To him, the rulebook was not a moral gospel, it was an engineering specification. If the officials left a loophole wide enough to drive an 11-foot fuel line through, failing to exploit it was an insult to the craft of mechanical engineering. In 2001, Smokey published his legendary 3-volume autobiography titled Best Damn Garage in Town: My Life and Adventures. It remains one of the rawest, funniest, and most brutally honest technical memoirs ever written in American literature. Just a few months after its release, on May 9, 2001, Henry Smokey Yunick passed away at the age of 77. The racing world mourned him, but more than that, they recognized that an entire era of motorsport had died alongside him. Smokey was the last of the true mechanical outlaws, a pilot, inventor, engine builder, aerodynamicist, and philosopher who treated physics as the only authority worthy of his respect. Here's the final lesson Smokey left behind for every gearhead and fabricator alive today. Never accept that a machine has reached its absolute peak simply because the factory manual says so. Every engine, every chassis, and every regulation has hidden potential waiting to be unlocked by someone daring enough to look past the surface. If you understand physics better than the person writing the limitations, you will always hold the ultimate winning hand in the very end. So the next time you see a race car tear down the front stretch at 200 miles per hour, or you watch a modern team try to slip a subtle aerodynamic trick past the laser inspection cameras, remember where that DNA came from. It came from a smoke-filled shop on North Beach Street in Daytona. It came from polished cast iron, oversized fuel lines, dropped Chevelle floor pans, and a mechanic who understood that the real race does not take place between the green and checkered flags. The real race takes place inside the rulebook, where the only true limit is the boundary of your imagination. Take care, and I will see you in the next video very soon.